Welcome to another video. Do you know that this x raised to x is equals to 4 raised to x? That we can find two solutions for the value of x, which the left hand side will be equals to the right hand side. So we are asked to find the value of x. So good people, in case you're watching for the first time, please subscribe. For the returning viewers, I really thank you. Continue turning your notification on. And straight away, let's dive into the solution. And the first approach, I should be able to predict by testing if I can get the value of x easily through inspection. I can start with the smallest value of x if the right hand side will be equals to the left hand side. So let's say if our x is equals to 0, then this particular equation is going to change to 0 raised to power 6, which of course I'm going to get 0. And on the other side, 4 raised to power 0, you get 1. So it is obvious that x cannot be equals to 0 since the left hand side is not equal to the right hand side. So we are doing by inspection. When x now is equals to 1, so on the other side I'll have 1 raised to power 6. Of course I'm gonna have 1. And on this other side, 4 raised to power 1, we're gonna end up with 4. Next, let's try when x is now equals to 2. So this becomes 2 to the power 6 is equals to 64. And on this other side, 4 to the power 2, you end up getting 16. So you realize that on my left hand side, it has really jumped big from 1 to 64 whenever x is between 1 and 2. And on this other side, it was 4 to 16. So as the left hand side grows bigger and bigger, exponentially bigger, but the rate at which my right hand side grows, it's not as far much exponent as the other one. So I can say that my value of x now that I'm gonna get will be in the range between 1 and 2, between this value and this value. That is where I'm gonna get my value of x. It is falling in between because this is 1 and this is 64, and this is 4, this is 16. It's inside there. So let's test to the left. To the left side of the curve, that is the negatives, I know if x is 0, then it is 0 and the other side is 1. Let's test if x is now negative 1. X is equals to negative 1. Then on this other side, I'll have negative 1 to the power 6. Of course, I'm going to end up with 1. And on this side, 4 raised to the negative 1, I'm going to have 0.25. You realize that toward the negative side, as the left hand side becomes smaller, the right hand side is still on the positive side. So it means before we reach to that negative, the value of x will also be in the range. So the second value of x, this is on the first one, this is the second one, is going to fall in between 0 to negative 1. 0 to negative 1, somewhere there. So that means when I try to sketch that curve, the curve gonna look like this. We're just trying to sketch it so that 4 raised to power x, the graph is going to behave like that. That is the graph of x, the graph of 4 raised to power x, while the graph of x raised to power 6, remember here this one was 1, and when it is 1, the other one is when x is so this is 0, so this other curve is going to start from here and it grows exponentially longer like that. So this is the graph of x raised to power 6. So if this is 1 and this is 0, and then this is gonna be equals to maybe 1 somewhere there. 1 is there and 2 is there. So end up realizing that they are meeting somewhere between 1 and 2. So then I say there, and then if this is -1, negative of 2, then this curve is going to meet at those 2 points. We're just sketching the graph of x to the power 6 and 4 to the power x. So the big question is, how are we going to calculate the actual values of these 2 points? So solution, or the first step, my first step, I know that according to the laws of exponents, if you have a raised to m multiplied by n, then this can be altered as a raised to m multiplied by the power as 2. So you realize that if you have x to the power 6, this can be written as x to the power 3 multiplied by 2. Very nice. And when you have 4 to the power x, I can rewrite this as 2 to the power 2 to the power x. So the power law of exponent. So rewriting them in this form, I'll have x to the power 3. Then I'm going to take 2 outside. On this other side, I'll have 2 to the power x. And then taking 2 outside. So up to this stage, please kindly remember to subscribe, turn the notification on. You want to leave a comment, watch our other tutorials. We have a series of them in our playlist. So it's evident that these 2 and these 2 are gonna cancel, so that my new equation changes to x to the power 3 now equals to 2 to the power x. So since the power is unknown on this other end, the best approach to do is to introduce the ln on both sides of this equation, so that I have ln of x to the power 3 is now equals to ln of 2 to the power x, and then dropping the powers, this changes to 3 to the ln of x is now equals to x to the ln of 2. ln is our natural logs. So at this stage, I want to bring the x on the other side and the numericals on one side. So I'll have ln of x divided by x is equals to ln of 2 divided by 3. Then you need to recall that the power of exponent, when you have an exponential equation, x can also be interpreted as taking the exponent of the ln of x. So this will help us a lot. So wherever I have x, I want to substitute this. So it's going to change to ln of x divided by the exponent ln of x, which means that this is equals to this, should be equals to ln of 2 divided by 3. Recall again that a raised to n divided by, let's say we're gonna call it when you have a over b, then this can be written as taking the power up as a multiplied by b raised to negative of 1. So this is what I want to do here. So taking the exponent above, I will get ln of x multiplied by the exponent to the negative of ln of x is now equals to ln of 2 divided by 3. It looks now interesting. So guys, my next point, since I want to introduce the w function and the Lambert W function, also called the product log function, which says that when you take the w of a to the exponent of a, then this implies that the answer now becomes a. And for me to make sure that this and this are similar in this other equation, since this one is ln of x and this is negative ln of x, I want to multiply all through by the negative. So what I do on this side, I also do it on the other side. By multiplying by negative, then I want to have negative to the ln of x multiplied by the exponent to the negative of ln of x is now equals to the negative of ln of 2 divided by 3. Just taking the negatives on both sides. So now this, I'm gonna call this a, and also this one is a according to the w function. So taking the w of the two functions on my left hand side, I want to remain with the negative of ln of x, since this and this are the same, is now equals to taking the w of negative of ln of 2 divided by 3. So at that stage, this power can come up, and then I want to introduce the exponent so that I end up with getting the value of x. So I've just introduced the exponent on both sides so that taking this up, recall that we said x is equals to the exponent to the ln of x. So also this I'm going to change to, I've just taken this on the other side so that I have ln of x raised to power negative 1 now equals to the exponent of the w of negative ln of 2 divided by 3. So it goes without saying that this side I'm going to end up with x raised to negative 1 now equals to taking the exponent to the w of ln of 2 divided by 3. So guys, at this stage, for me to remain with x, I want to take the reciprocal on both sides of the equations. So I'm going to end up with x is equals to, taking the reciprocal on this other side, I'm going to end up with 1 all over exponent of negative ln of 2 divided by 3. And then at this stage, guys, is where I'm going to take my scientific calculator and compute this function. When you take your scientific calculator and compute exponent of negative ln of 2 over 3, you want to end up with 1 all over. This is w. So I'm going to get exponent of, I've just punched that in my calculator, and I'm getting negative, I'll write everything, 0.37 5382 872. So my x now becomes 1 all over. I'm going to take 0.7280 844 1182. So it means taking the reciprocal of this value, I shall end up getting my value of x as reciprocal of this. The value of x now becomes 1.373 as the required value of x, the first one, which we predicted that the value of x was into that range. And guys, I want you to try calculating the second value of x, and we shall get that the second value of x, which falls on the negative side, will be equals to negative 0.77. So the first one and the second one. So good people, thank you for watching up to this far. I hope you've learned something. Kindly leave a comment, share. You can turn your notification on, and most importantly, support by subscribing. Until we meet again in the next one, goodbye for now.